please welcome Loren Dyer. She's currently doing a PhD. We should probably talk about it.
Hi, I'm Loren. I'm a PhD candidate here at Curtin, and today I'll be talking about robotics and spatial experiences, particularly using Arduino during the design process. So by way of introduction, when we talk architectural theory, we often speak as if design kind of lives within the designed object or the space. And this comes about by the design intent informing the material measures that we make in order to design a space. This is the designer's input. Then the occupant comes along, perceives these material measures, and interprets them into some sort of response, be that behavioural or emotional or conceptual. We even go as far as to try and codify the material measures that we can make and the sorts of responses that they might generate so we can be more sure of our designs or spatial experience in the future. So when we talk this way, there's quite a distinction between what the space does and what the occupant does. So the occupant in this case is the active participant in meaning making, and depending on how you want to think about it, the designer is also the active participant in the meaning making by encoding meaning within the building. So in this sort of dialogue, the space itself is quite passive. It remains the same whether or not it's being perceived, so it just kind of sits there waiting to be looked at, essentially. Or even worse, maybe it's nothing more than a surrogate for the designer's intentions, so it's simply a byproduct of the communication between a designer and an occupant. But what if that wasn't the case? What if our space could do more than just sit there waiting to be perceived? Like many people my age, I grew up on fairy tales, on Disney, on computer games, on all these fun things where space is active in meaning making. It doesn't just sit there hanging around waiting to be perceived. It sings, it dances, it springs up out of nowhere and it disappears again. It walks across the countryside waiting to plop itself down somewhere. And that's my kind of space. I like moving space, I like space that has its own agency, and I like magic space. So, unfortunately, the world of Disney, you don't have to contend with the laws of physics. In our little Newtonian world, you do. And the closest I've been able to come to try and code this magic feeling into space is through robotics. The platform I use is Arduino. So today I'd like to talk about a project I worked on in 2013. The project was called Third Place, and it worked as my own introduction to designing with robotics. Mostly I'll be talking about my design process, as I attempted to translate a spatial experience using a tool that I then had no familiarity with, and sort of the ways that impacted the design process. So I'll introduce you to the project first. This is the stunning video captured by the Curtin PR department at exhibition. And this screen kind of is meant to sit in front of another surface, and it opens and closes to respond to a user, who is in this case me. Sorry. Does anyone know how to get rid of that box? That's annoying. There we go. Okay, good.
You don't, Lauren, I don't think anybody does.
Better. Okay, so starting at the beginning, or at least at a beginning, the beginning of 2013 saw me deep within an urbex binge. So for those of you who haven't come across urbex before, it's a term that's a contraction of the two words urban and exploration. And it's a movement of sorts that directs purposeful occupation to places that are outside of the maintained urban networks. So this sounds awfully conceptual, but essentially what it boils down to is a lot of sneaking around in abandoned places. These are usually places that have something to do with the running of the city, so places that are or were once important to the way we live our lives, like institutions like hospitals, infrastructure like storm drains, the sorts of places that we usually don't think about and we don't occupy, but are so important to our lives. So you may have seen photos like this floating around the internet. These are the sorts of places I'm talking about. And the people who appreciate them usually appreciate them for their dilapidation. But society in general doesn't appreciate them. Like, you have to sneak. It's not a welcomed experience for people to go and visit these. So I was interested in why people came to these places, what sort of experiences they have there, what kind of meanings do they create, and how and why are these spaces valuable. So to start my project, I selected a site, an urbex site in the outer rings of Perth. And I did a site investigation, media analysis, questionnaires, and lots of reading. And I ended up isolating some spatial experiences that were important to the way that this site was constructed and what it meant for its occupants. And then I tried to translate these into an experience that was open to everyone without losing that special magic quality that made the space what it was. So basically, I wanted these sorts of experiences to be had without the need to sneak around. So a couple of things about the sorts of spatial experiences I'm talking about. It became clear that the people who used the site didn't do so for the aesthetics, but it was more about working with the site in terms of movement and action. The things that these people could do at this site was very different to what they could do in regular space. Both materiality, like the physical structure of the site, and narratives were very important to the meaning-making process, and were both quite active within that meaning-making process. So the site was essentially perceived as acting on its occupants, as well as the other way around, and this came out through things like disorientation, negotiation, and shifting perspectives. So the site wasn't seen as a container for activities, it wasn't something to look at, but it was something with which both a narrative and an embodied relationship was negotiated between person and site. Importantly, the spatial conditions of the site, both material and narrative, they played a very active role in establishing this relationship. So I found myself confronted with a magic sort of space, and the trick became how I could visualise and promote or translate spatial relationships that formed this experience. The usual sort of tools that we turn to in architecture and design, documentation drawings, perspective drawings, even 3D modelling, I didn't feel like they were a good fit for this project because they could represent spatial experience to one degree or another, but they were unlikely to recreate that experience or to translate it in a way that a person who hadn't met this site or wasn't used to reading drawings could appreciate. So I turned first of all to animation. This was my first port of call to try and express how people experience the site. There's a lot of theory that says that we react to moving representations like we would an event unfolding before us. This is mainly to do with our visual culture and the way that we're used to interpreting images in that immediate fashion. This is referred to as haptic visuality, which basically holds that receiving images through the eyes is the equivalent to being touched. When people say this, they kind of mean that the emotional and behavioural responses that you have to images can be very similar to these sorts of things you can have to things that are there in flesh 3D objects. So this animation was made through dissecting photographs of existing elements of site, layering narrative elements on top, setting it all to motion using stop motion, and I ended up with this sort of story about spatial experience, essentially. So, to me at least, this seemed to express my analysis of the experience fairly well, but it was missing some important elements, and one in particular was reciprocity. So I found in my site that it was really important for the person and the site to have equal or equivalent stakes in producing meaning. And although the animation might affect a viewer in a similar way to if they were exploring the site, there was no opportunity for the viewer to impact the animation or indeed the space which it represented. So In this case, the occupant would have little agency to negotiate their own spatial experience of the space. So what this led me to was that the design response needed to allow the opportunity for reciprocity. It needed to allow equivalence between the impact of the space on the occupant and the impact of the occupant on the space. So my translation had to start in the material world. It had to be a real physical thing to allow for this negotiation to happen. But it had to appear as if it was acting on its own. It had to be an independent sort of element to maintain its own role in the negotiation. So the big question is, how can you make the real world act as if it were independent? And that's how I came to robotics, as a way essentially of animating the real world. And as I've said, the platform that I use at the minute, at least, is Arduino. So I'll take you through what it is and what it can do quite quickly. The term Arduino refers to the microchip, the processor on this board there. So it's a pre-packaged board, and it has on it a microchip, some simple processing circuits, and a bunch of pins that you can plug stuff into, essentially. It's basically a small, very, very unpowerful computer. It doesn't run an operating system or anything like that, but you can plug it into your laptop, use a DOS-based program, and load code onto it. So the joy of it is that you can mix and match inputs and outputs for this thing, which means that you can sense different things in the environment and then drive different things in the environment to make changes in response to environmental conditions. And you tie these inputs and outputs together using C++, which is a coding language which is fairly easy to pick up. And the other great joy of it is that it's mostly Creative Commons, which, are you guys familiar with Creative Commons? Yep, awesome. And there's a huge developer community. So basically any component that you can buy, there's already somebody who's done like 3 million things with it, posted their code online. You can select little bits, chop it up, change things to make it do what you want, and tie it together in the ways that you want things to act. So that's sort of how you can use this to produce something. But use in robotics also impacts on the design process itself, not just the outcome. So like any architectural design process, the form of the project, it's tested against the concept and the initial design requirements so that you can come up with something rigorous that responds the way that you want it to. But it also needs to respond to the capabilities of the material and to the tools that you use. So when using robotics, this relationship becomes much more tool-directed because there's a huge interdependence on the parts that you need to use. So for any robotics project, you've got a series of components, and these are your inputs and outputs. They might be things like, well, sensors are usually the inputs, but they might be microphones, sound sensors, that sort of thing. And outputs, which can be things that produce sound or movement, things like that. Then you've got the mechanics of making objects move, which is all kind of simple physics stuff. You've got the code that links the inputs and the outputs together, which is the phrasing and the way that you tell the computer to act, essentially as language. And then you've got the electrical circuitry that has to drive it all, powers everything. So when you add aesthetic expression to this, you can see it's kind of more of an afterthought, like there's so much more to consider, and aesthetics takes a bit of a backseat. So for this project, my initial design requirements were much more to do with behaviour than they were with form. I did have a couple of initial requirements for form, and this was sort of my first party, my first diagram that I went on from. The form had to be read as flat or two-dimensional, as an articulated surface so that it could have a screening effect. And the scale of the panels had to be related to the scale of the body in order to encourage a sort of one-on-one communication. But in terms of behaviour, you have a bit of a bigger list. So the screen had to maintain boundary. It had to sort of open and close by itself. It needed to react directly to the body of the user. it needed to invite engagement, it needed to spur people to come and talk to it, essentially. So it had to have an element of reveal about it. It had to sort of be dramaturgical in the way that it addressed the space behind it. And the space behind it had to kind of disappear when the occupant wasn't there, so that meant it had to open and close, essentially. Importantly, it had to not try to interpret the space for the user itself. The user had to be able to create their own relationship. So these initial behavioural requirements, that's what drove me to select the components that I did, and they were the beginning points for expressing the design. So the three major components that I used were an input and two outputs. So first of all, I needed a sensor as an input to detect the body of the user. And there are lots of ways to do this. You can use motion sensors, heat sensors, you can do video analysis to find humanoid shapes. But in the end, I went for an infrared distance sensor. Although this doesn't allow you to distinguish between human and non-human objects, it's low on processing power, and it allowed me to set distance thresholds so that the screen could act in different ways depending on where somebody was standing, how far away from it they were. And I needed a motor to drive the response. I picked what's called a servo motor over a DC motor. If you guys have ever played with remote control cars, they use a DC motor. You give them power and the motor just continually rolls in one direction. But a servo motor is stepwise and it's bidirectional. So you can give it a little bit of power and it will just move 1 degree at a time until you tell it to stop, and it can go both ways. And the last thing I needed was a big old amber LED to moderate the relationships between light and dark, and that was to sort of enhance a sense of reveal of that anterior surface. So then my next step was to put it all together. So constructing the circuit was one part of this, the electronics part, and then I needed to code up the relationship between the one input and the two outputs, and set the distances and the times of response. Only once I had my functioning circuit did I turn my attention to form. And when I did, it became quite apparent that most of the form had kind of already been decided for me. It was quite firm because of the need to accommodate the components. And I'll just show you how that works. So the major driver of the form was actually the mechanics of translating that rotational movement of the motor into a sort of linear drawing movement so that it could open and close. So to start with, the size of the motor directly impacted the depth of the panel. So that's the depth as read away from the user. And that impacted the depth of, or the height of the arm as far as it stuck out from the surface. The arc of the swing of the motor would kind of have an impact on the circumference of the face. And it also had an impact on the height of the arms in order to get the right angle so that the downwardness was equivalent to the sidewaysness. Because the panel face was proportional, because it had to cover a whole surface, the size of the face impacted the size of the arm. And since I was using other robots, i.e. the laser cutter, to make this thing so that I could get the right level of correctness to it, the materiality of the panel was actually quite fixed itself. And because I only had a few materials I could select from, I only had a few material densities. So the material density determined the weight of the arm, and then the weight of the arm determined the torque of the motor, which in turn decided the size of the motor, and we're back at the start again. So it's quite a circular process. The size, materiality, and the form of the panels are all interlinked and respond to both the components and the methods of construction. And what this meant, essentially, was that the form had to be worked out iteratively. So the project morphed in lots of different ways at once. So one of these was form, but there was also the circuitry and the the code and the power of the components. And they all, once you make a change in one, you have to change all of the others, essentially. What I was finding through this was that, yes, my site played an active role in constructing the person-site relationship, but I was stuck in a process too. And my project was very active in essentially making itself and thus deciding the way that the site was translated for other people to experience. So I didn't feel very in control in this process. There were a lot of external things happening to me. It was quite a chaotic process. And I felt more or less like it was the project itself that was in control of me. Now, I'm not sure how you receive that, and you can say that within theory, every error in a robot is the result of a decision or a lack of decision by a human. But for me, there's a certain point where this starts losing meaning, because if you can't tell what to fix, then it may as well be acting on its own. I'll take you through a couple of minor things that, minor errors that can be responsible for behaviour that you don't expect. So the first one is grammatical errors in code. And I'm not sure if you guys have heard this grammar joke before. Basically, a panda walks into a restaurant, he has a lovely meal, takes out his gun, shoots everything inside, and then runs away. And it comes from this encyclopedia entry. The problem here is this comma. So if we replace that comma with a colon, suddenly we've got a nice passive panda who just does his own thing. So a similar mistake in code can be just as disastrous as a hungry and homicidal panda. As an example, this was part of the code that I used, and this code, this first bit, means that if somebody is within 30 centimetres of the sensor and the motor isn't completely open, then the motor will open one position and wait a little while before it does anything else. But if somebody isn't within 30 centimetres and the motor is open, then the motor will close one position and wait 30 seconds before it does anything else. But if we add a semicolon here, this code means that if somebody's standing within 30 centimetres of the sensor, then it will continuously open and close one position and look like it's having a bit of a fit. If you're interested, this is because the two lines, the action below that first if clause, which the computer is trying to decide whether it's true or false, are no longer dependent on it. But that's probably not of much interest to you unless you do this stuff yourself. The second is linked pins, and this got me going for a very long time. An Arduino board has three types of pins. It's got an analog in pin, or a variety of them. And this returns voltage between 0 and 1024, so you can read the degree of things and react appropriately. It has digital pins, which are just on-off, and then it has pulse width modulation pins, which turn on and off very, very quickly, and the speed with which they turn on and off determines what degree of thing is happening. So tying components to one of these pins can put others out of action, or can make them behave erratically. And since this is hard-coded onto the board, changes from board to board, it can be really, really tricky to detect. And the third thing is robot dance, which I find terrifying. I've got no idea what does this. I think it might be a power issue. Essentially, you plug the thing in and it just spasms and spasms and spasms and makes loud noises and scares the living bejesus out of the designer. So basically, this project for me wasn't just a communication between the occupant I was designing for and the finished product, but it was also a huge negotiation between me and the project as it was developing. So the product isn't driven by the designer, but it was an active negotiation between me as the designer and the tools that I was using in order to implement my spatial experience. You can kind of say this is true of any architectural project. You have to know how steel works, you have to know how brick works. The difference to me is that robotics really seems to answer back a lot more than brick or steel does. Okay, so eventually eventually my project and I, we came to some sort of agreement about the spatial experience that would end up being translated, and we ended up here. So conceptually, this was a project that was meant to be applied as a continuous screen in order to frame an element of forgotten space. And it allowed inhabitants to interact with the space in a way that they negotiated themselves with the screen, with the space, with the occupant. In terms of the prototype, this is what it looked like when it was hung on the wall. There were 4 panels in the end, and it had 3 actions, or at least 3 programmed actions. The first was the invitation. So this was just a little thing that was meant to attract the user's attention and draw them closer to the screen in order to interact with it. And it just meant that if somebody wasn't very close to it, the motor would open and close little bits so that the arms kind of flickered a little instead of like scattering off somewhere. So it's not a huge movement, but something you might catch out of the corner of your eye. The second was the response. So somebody approached this within a personable distance, as you might if you were having a conversation with someone. The panels would open and connect the users to the surface behind. And the third action was the residue. So in order for the occupant to sort of leave some of their impact on the space, if 3 of these panels opened at once, so that there was one whole triangle open, essentially, if that makes sense, then that would stay open for an indeterminate amount of time, which was just done through random number generation, so that if someone was standing in front of it, you might get the rough shape of their body, essentially, after they'd walked away. And all of these actions, they use the same hardware, which we discussed with the motor, the sensor, and the LEDs, but there was a lot of mechanical stuff going on inside as well. But they use different code for each different action. So this is it as it was hung up, and you can see the invitation happening just there, flickering about, and then a very tired designer comes up and stands in front of it, and it begins to open up. So I'm putting my left hand down there now, and this is a linked pin issue. So this one won't open until the other one's shut, which is a bit of a shame. The problem with that was that I had 4 of these panels connected to one board, and I really should only have had 3. But that's okay. Alright, so that's that. In summary, I guess what I've wanted to try to communicate to you today is that using robotics is an excellent way to make your spatial project more active, to promote a stronger reciprocity between an occupant and the space that you're designing. It can also be used to layer narrative elements on top of the space, and the way this works is that it still retains the embodied engagement of person and space, or it can even enhance this. And the third point is that designing spaces with robotics can change the whole design process. It adds additional design restraints and makes each part of the project far more dependent on the other parts. And I'll just finish off by saying that since my main conceptual point about this whole thing was that the prototype was quite active in the spatial experience process, I made another animation to try and express this. So this one used a lot of photography, stop motion, and Photoshop. It's actually edited frame by frame to create an animation that demonstrates the independence of the project. So in many ways, this was kind of an answer to my earlier site-based animation, which showed the independence of the site. The whole animation shows the project constructing itself and later interacting with the occupant. Yeah, but I don't think we'll get that far. So, does anybody have anything that they'd like to ask?
How long did this whole process take you?
Well, this was a 1-year honours thesis. So the first part was the site analysis, and that took 14 weeks. And then the second part was the developing the robotics, and that took another 14 weeks.
Did you know any coding before you embarked on this? No?
I had a bit of experience with DOS, so I kind of got the idea about command-based programming, but I certainly didn't know C or anything like that, so it's good.
So what did you find was the easiest or best way for you to learn that? Because it's not easy. I've tried myself on Code Academy and stuff like that. It's not.
I guess, surprisingly, that's not the bit that I found most difficult. I think that has a lot to do with the fact that a lot of this stuff is online. So the second you get something new, you can make it do something simple with what somebody else has written. And then it's just kind of a process of analysis. So you can sit through, you can change a little bit, figure out what that does to the project, change it in other ways, and then eventually you kind of get into the swing of what part of the words do what to the output. So I guess in answer to your question, having a go is probably the best way to learn it.
So the basics of your programming were already open source then, I'd imagine?
Yes, yeah. So let's see, okay, so when I got the sensor, there was an open source script, sketch, they call it. There was a sketch to read off the sensor and list it as a series of voltage values on the computer. So once you've got that, that's your input. Then you can get the output, which is the motor. There's a script that tells you how you move it forward one position. Then you just have to put the two together. Yeah. So the program that you use with Arduino, it actually comes with a really decent help section where you can click on, it gives you a list of commands and you click on it and it'll tell you what it does and then give you an example of how it's used.
Cool.
Kind of like a dictionary then.
Anything else?
So, beyond the pragmatics of getting on top of this system in 14 years, which is quite astonishing, I happen to know that this project is deeply steeped in theory. So, I mean, it's quite an astonishing project. And I'm just wondering if you must have given some thought, and I think you have the way to talk about it, to our changing relationship with technology. I mean, it's been evolving over at least 100 years now.
Yeah.
And
so, sorry, what's the name? Did I cut you off? I guess that's the question of our age, really, at the minute. The type of technologies that we have are now quite different to the types of technologies that the industrial age sprang out of. And the way that they can mediate the things that we can do and the way that we perceive space and the actions that we can perform in space are quite pronounced. Often they're quite hidden from us. So in terms of robotics, I think it's a wonderful tool because it actually gets you acquainted with the back-end workings of these things so that as part of your own learning process, maybe you're not so scared to pull apart your iPhone when you drop it and replace a part, you know, that sort of thing. Yeah. That has a lot to do with my PhD, I suppose, about the ways that technologies can impact the things we can do.
yeah, I mean, in terms of the human condition, in terms of our humanness, that we are beginning to have relationships with technology. Are you able to comment on that? Or maybe this is a little bit of observation.
Yes, I can comment on that. I don't know how popular my comment will be. I actually don't believe there's really such a thing as human anymore. It doesn't really seem to be a term that makes much sense for me. I think the term human was kind of a word that we used to decide whether we had to have an ethical relationship to the thing that was standing in front of us. And I think that's probably more of, should be judged more on what that thing can do and the way you feel about it more than thinking about the constitution of human beings and what makes us human. So for me, this project was definitely quite human. I used personal pronouns to describe it. I got angry with it. I got overjoyed with it. It was kind of like a little child. For me, I wouldn't hesitate too strongly to call it a person. And I think that the kind of, that localization of human for me is a bit strange. I don't really get it anymore.
Do you think it changed?
Human and what is not is not. It's just a different framework with which to pull out your meaning, I guess.
Another question. I'm not sure, maybe this is incredibly prosaic to ask, but what kind of application, do you see there's some kind of application for robotic surfaces? I mean, these ideas, maybe not robotics, I mean, how do you see it manifesting?
In two ways. For me, it gives space the agency that it deserves. So I don't think it really matters what you do with it. It's more that the byproduct of that is that space is more active, has its own stake in creating a relationship with a human being. The other thing is that it empowers a human being as well. So in this project, I was looking, well, a kind of sideline of it was heritage, and often the way that we treat heritage buildings decides a lot of things for the person who's going to interact with it. So, you get your didactics and you get your the things that are restored and things that aren't restored, and it's presented as a linear narrative so that you have to read it historically. For this project, the idea was just to leave it all alone and to let the user establish their own relationship. And I think that's something that can be generalised to robotics projects in general, at least these kinds of robotics projects. There are other kinds that impact in different ways. Right.
Okay, can we thank Loren?